Hello students, welcome back to Akshar online IIT classes. I am your chemistry faculty S. Mohan. We are doing the chapter solution and till now we completed 3 synopses of solution. And in the last topic we discussed about the vapor pressure, lowering of vapor pressure, relative lowering of vapor pressure and Raoult's law, right? And based on that we have solved some questions also. Okay, today I am going to explain you a new topic, means solutions only, but next topic. Okay, so we are going to discuss about the synopsis 4 today. So students, synopsis 4, what are the synopsis 4? Students, here normally solutions, already we discussed about, we are discussing about the solutions only. A mixture of 2 or more substances is called as a solution, right? A homogeneous mixture of 2 or more substances is called solutions. And in that particularly we are discussing about the binary solutions. Binary means what? 2. A solution which contains only 2 components, like salt and water, something like this, which consists of only 2 components, that's called a binary solutions, right? And in the previous class onwards, we are discussing about the liquid and liquid type of solutions, right? Liquid, like water, ethanol, okay, like this, liquid solutions, okay. So now here, solutions. Solution students mainly classified into 2 types. Solutions are mainly classified into 2 types. One are called ideal solutions. What is the first one? Ideal solution. Then other one is what? Non-ideal solutions. Right? Ideal solutions and non-ideal solutions. Now, what are ideal solutions and what are non-ideal solutions? So, in the previous class, we discussed about the Raoult's law. Did you remember? So, we discussed about the Raoult's law. So, here ideal solutions means what? The solutions which obey means what? Follow. Yes, you are the obedient students, yes or no? So why? Because you follow the instructions given by your teacher, right? So the students who follows the instructions given by the teachers or parents or elders are called what? Obedient. Yes or no? So you are obedient, I hope. You are following what are the teachers giving the instructions to you. Okay, right. So here, ideal solutions means what? The solutions which obey Raoult's law. Raoult's law. Under all concentrations, okay, all concentrations and temperatures. Okay, so these solutions are called ideal solutions. So what are the ideal solutions? The solutions which obey, means which follow the Raoult's law. Raoult's law under all concentrations and at all temperatures are called ideal solutions. Now, what are non-ideal solutions? Very good, that's all. So, which do not obey, okay, which do not obey Raoult's law are called non-ideal solutions, that's all. Clear? Okay, so which obey the Raoult's law, the solutions that obey the Raoult's law are called ideal solutions. The solutions which do not obey the Raoult's law are called non-ideal solutions. Till here clear? Sure. Now let's go to the next page. So first we discuss few properties of ideal solutions. Okay, ideal solutions. Just few properties we discuss. Okay, not much more, not required here, but just okay, few properties we discuss. So ideal solution means what? For example, okay, we are taking two solutions. Okay, this is beaker A and this is beaker, another beaker B. Okay, otherwise we take two beakers, and this I am taking the some solution A, and here I am taking the some other solution B. Which color? Can you see? Yellow. Okay, I'll take yellow. So here I am taking the other solutions. Okay, this is a solution A, this is a solution B. Alright. Now, if I mix both together, right friends? If I mix both together plus, okay, if I mix both together, then what happens? I'll get the some solution, right? Okay, so chalo, this is a mixture. That is what A plus B, both are mixed here, right? So here if you see that, here for ideal solutions, we have some conditions, okay, some conditions are there. What are those conditions means? For example, if you take the volume, if you take this is 100 ml volume, this is 100 ml volume, 100 ml of A solution, 100 ml of B solution, we both are mixing together, then what happens? What is the volume of this one? 200, yes. So, the volume of A plus volume of B is equal to volume of A plus B. That's all, very simple. Okay, if you are taking 100 ml and 100 ml, we are mixing, so that becomes water. Okay, 200 ml of solution. So, volume of A plus volume of B is equal to volume of A plus B, right? Now here one more important thing here, students. Here, delta H. Here, delta means what? A change. Delta means what? Change. And H means what? Heat. So, change in temperature. If we mix both the solutions, the change in temperature does not take place. So, the meaning is what? Is equal to 0. No change. Okay. So, this also in this way, if you want to write, we can write a delta V is equal to 0. Okay. So, there is no change in the volume, no change in the temperature. Right. And one more important thing, that no chemical reaction also takes place between them. No chemical reactions takes place between these two. That's all. And no chemical reaction should take place between these two components. Right here, two components A and B, between A and B. Next, one more important thing, that here you see, you know that there is a force of attraction. Already you might have said in the lower classes, if the solid is there, the solid between the two molecules, there is a strong force of attraction is there. Liquid is there, between the molecule there is some force of attraction, yes or no? So if I am taking the liquid A, there is also some force of attraction exists between these two A to A molecules. So the force of attraction between A to A, okay, and the force of attraction is B to B. If you check here, the force of attraction between A to A or the force of attraction between B to B is equal to, very important point, is equal to the force of attraction between A and B. Means that I mixed both the solutions, no? So here the force of attraction between AB will be equal, same. Okay, so these are the points. So once you can see, students, here, if you have a material page number 43, if you have a material, once you can see in the page number 43, so okay, here you can see the page number 43, there is an ideal solution. Okay, ideal solutions are the solutions in which a solute and solvent interaction are similar to solute-solvent interaction. Means what? AA attraction or BB attraction is equal to AB interactions. Okay, and for that solutions, what are the conditions? See, students, here they obey the Raoult's law. This already we discussed here. So ideal gas equations obey the Raoult's law. Okay, see in your page number 43, can you see here? Okay, material is there now with the next delta H of mix is equal to 0. So delta H is equal to 0 means no change in the temperature, and delta V is equal to 0. See, delta V is equal to 0. The sum of the volumes of individual solutions is equal to sum of the volumes. Okay, the total volume of the mixture, and no dissociation or association will takes place, means what, no chemical reaction. So here no chemical reaction between the solutions takes place. Okay, and do not form azeotrope. Azeotrope I'll explain you. So these are the things. Now here the most important point. See here. Now these are very important because in the next after completion of this chapter, means this lesson, we are going to solve the questions now. So most of the questions will be from here only. Okay. So here whatever the questions are there, these examples you have to follow. Okay. So what are the examples you can give for the ideal gas solution? So you can see a benzene plus toluene, page number 44. You can see a benzene plus toluene. Okay. Next mode, what are they? Hexane and heptane. Hexane and heptane. Okay. And more, what are they? Ethyl bromide and ethyl iodide. Ethyl bromide. Okay. And ethyl iodide. Okay. More, what you can give? Chlorobenzene and bromobenzene. Chlorobenzene and bromobenzene. So these are some of the examples, students. Okay, till here you understood any doubt? Chalo, last and final 1 minute. So within 1 minute, while I explain you what are the solutions. So solutions, a binary solution means what? A homogeneous mixture of 2 or more substances called binary solution. Solutions are classified into 2 types, like ideal solutions and non-ideal solutions. And ideal solutions means what? Which obey the Raoult's law are called as the ideal solutions. Which do not obey the Raoult's law are called as the non-ideal solutions. So ideal solutions, some qualities should be there, some conditions, some properties of the properties are that the volume of A plus volume of B is equal to volume of A plus B, and the change in temperature is 0, means delta V is equal to also 0, no chemical reaction, and the interaction forces between A and A molecule or B and B molecule is equal to interaction between the A and B. And example, benzene, toluene, and hexane, heptane, ethyl bromide and ethyl iodide, and chlorobenzene and bromobenzene. These are the ideal gas, ideal solutions. Is this clear? Simple, no? Easy? Very simple. Chalo. Now we discussed about what ideal solutions. Now let us see what are non-ideal solutions. So non-ideal solutions means already just now I told you that which do not obey the Raoult's law. Which do not obey the Raoult's law under all conditions. So what are the conditions we studied here? You can see here. What are the conditions we studied here? Those conditions will not follow in the non-ideal solutions. If you know one thing, other thing you can say, okay, like you see here. So here, if you mix both the solutions, both the solutions total volume may not be equal to the solution. Okay. So and here the temperature also maybe changes. So delta H is not equal to 0. Here is equal to 0 for ideal solutions. So the same properties, just opposite. So delta H is equal to 0 here. In the non-ideal solution, delta H is not equals to 0. Means what? The temperature may increases or change in the temperature. Okay. Maybe increases, maybe decreases. Delta V is not equals to 0. Maybe increases, maybe decreases. And here the force of attraction, see here, the force of attraction means the interaction forces between A and B and B is not equals to A and B. Means what here? So it may be less than A or B or may be greater than. Is not equal. Is not equal to means what? Two conditions will be there. No. Okay. So it's not equal to means what? For example, your two students are there, right? You are writing you have written the exam and your teachers given the papers to you. So your two students' marks are not equal. The meaning is what? One student's marks may be greater than the other students or may be less than the other students. Clear? So that then we can say that they are not equal. So here also same students here. So here the interaction between A and BB is not equal to interaction between the A and B, means solute and solvent. So the meaning is what? Here the interaction between A and B may be greater than these both or may be less than these both. Clear? So they are called non-ideal solutions. Clear? Any doubt? Right. So now non-ideal solutions. Now once if you open your material, so in the page number 44, just there is see a definition. Non-ideal solutions. Non-ideal solutions are solutions in which a solute-solvent interactions here. Solute-solvent interactions are different from solute-to-solute and solvent-to-solvent okay, interactions. So these solutions do not obey the Raoult's law, okay, for all concentrations and temperatures. Okay, the meaning is what? Delta H is not equals to 0 and delta V is not equals to 0. That's all. So they are called as the non-ideal solution. So remember this one, just not equal to put there. So that becomes a non-ideal solutions. Clear, students? Any doubt here? No. Sure. Now let's go to the next one. Okay. So now, just now I told you that in there is one word has come, azeotropic. Right? What are azeotropic? Now let us see. So here, if I mix the two solutions, okay, if I mix the two solutions, means two liquids, okay, like alcohol is okay, and water, something like this. If I mix the two alcohol, then the boiling point, students, very important here, the boiling point of the mixture remains the same. Means what? I'll explain. So here you see now azeotropic mixture and ideal and non-ideal solutions. Ideal just now we discussed, ideal and non-ideal we discussed, right? I'm not going to discuss about them. I just want to discuss non-ideal and non-ideal solutions which obey the Raoult's law, which do not obey the Raoult's law. And delta H is equal to 0, delta V is equal to 0. Here delta V H is not equals to 0, delta V is not equals to 0. Okay. Here interaction forces of solute and solvent molecules is equal to solute and solvent. Here the interaction between the solute molecules and solvent molecules is not equal to the solute and solvent. That okay. So chalo see now azeotropic solution. So azeotropic solution means what? Okay. So now an azeotropic mixture is a mixture of substances that has same concentration of vapor and fluid phases. Okay. The meaning is what? In the 9th class itself, in the second chapter in CBSE, in the second chapter you might have discussed about the fractional distillation. There is one topic in the second chapter. Okay. In the separation of mixtures, there is a topic called distillation and fractional distillation, right? So in the fractional distillation and fractional distillation, did you study? For example, if I take water and alcohol both mixed together, water and alcohol both mixed together. So here you see, here this is a beaker. For example, you think, okay, here I am taking water is also I am taking and alcohol is also I am taking. So water and alcohol both I am taking together. Okay, this is a mixture of alcohol and water. These both are perfectly mixed. These both are perfectly mixed. Now I want to separate them. How can I separate? Can I separate with the filter paper or filtration? No, because these both are the liquids, both are mixed together, so I cannot separate them. How can I separate? I can separate by using the process called fractional distillation. Which method? Fractional distillation method I use. Okay. So what is the fractional distillation? So here you can see here, you know, if I take the water, what is the boiling point of water? Loudly. Boiling point of water, very good. So that is 100 degrees Celsius, 100 degrees Celsius, right? Now if I take alcohol temperature, boiling point is how much? 78 approximately, okay? So 78 degrees Celsius. Is this clear? So now this both I mixed. Now I want to separate. Okay. So boiling point means what? Boiling point means what? The stage at which the temperature at which liquid converts into the gaseous state or vapor state. That's called boiling point, right? So now here these both solutions are mixed. I want to separate them. Then what I do? I'll maintain the temperature. Now I will heat. Okay. I will heat this solution. Okay, at what temperature I will heat? I will heat the temperature which is of between these two. For example, I am heating the up to 90 degrees Celsius. I am heating this at the 90 degrees Celsius. Right? So here What is the boiling point of alcohol? 78 degrees. Boiling point of alcohol is 78 degrees. Means 78 degrees, it will start converting from liquid state to gaseous state, right? So here alcohol is, because 90 here, so greater than 78. So now what happens? Alcohol starts converting into the gaseous state, means vapors. Whatever the water, no, because water boiling point is how much? 100 degrees Celsius, right? So we are heating only 90 degrees Celsius. So water didn't reach its boiling point. So water do not evaporate. Okay, water will remain as a water only, right? Now, but alcohol is what's happening? Alcohol is getting evaporated, means what? Converting into gaseous state. Now what I do? Here I'll close it and I'll fix one tube. So to this tube, these vapors of alcohol are going here in the gaseous state. Now here I cooled them. Here I cooled that gases. On cooling, what happens now? Again, I'll get the liquid of alcohol. What I'll get here? Liquid of alcohol, right? So here in this mixture, when I heat it more than boiling point of one of the component, that component is getting evaporated, is converting into vapor state, and then it's going through this one. But here, after coming here, what I'm doing? I'm cooling. Cooling means what? Condensation. I'm doing condensation, so again vapor will be converted to liquid. So here what I'll get here? Here I'll get only alcohol. I'll get what? I'll get only alcohol. And here what will be remain here? Oh, water will be remain. So here only water will remain. There alcohol. So I got separated both of this. Yes or no? So this is called fractional distillation. Fractional distillation means what? When the boiling temperature between two liquids is less than 25 degrees, then we use a fractional distillation that you can see in your textbook. Okay, so by this we can separate, right? So we are separating here. Okay, but here what happens? So here they have the different boiling points. Different boiling points. Water has 100 degrees Celsius and alcohol has 78 degrees Celsius. Right? So these both different boiling points are there. But students, here listen carefully, very important point. But students, here, if I mix water and alcohol in one particular proportions, if I mix alcohol and water in particular proportions, then what happens? They do not will have the different boiling points. This mixture will have same boiling point. The both means now we cannot separate them by using fractional distillation, because both solutions, both components mixture, okay, boiling point becomes the same. Okay, for example, if you see here, here what we are taking? Water and alcohol. Okay, so for example, you see here, I am taking the water and alcohol. And water I am taking the percentage of 4.03. 4.03% of water, and remaining how much? 95.97% of alcohol. 95.97% of alcohol. Okay, I am taking in this particular ratio, students. And now, if I mix together, then the combined boiling point becomes to be 78 degrees, somewhat 78 degrees. Okay, somewhat 78 degrees Celsius. Now, here we cannot, if I take the mixture in this particular ratio, now I can't separate. Here I can separate it. But here the same solutions, if I take in this particular proportion, in this particular ratio, then I cannot separate this water and alcohol by fractional distillation. Clear to you? Very easy. Okay, so that is it. So now, okay, see here, these mixtures are constant. Okay, so here you can see these two liquids cannot be separated by fractional distillation. Why? Because of similar boiling point of the liquids. Now both the solutions boiling point becomes the same now. Okay, actually alcohol is about 78, boiling water is 100, but here it will get both becomes similar. Okay, so there will be a variation, small changes of variation will be there. So something like this. Is this clear to you? So such type of solutions are called azeotropic mixtures. What they are called? Azeotropic mixtures are called. Okay. So now azeotropic mixture. Understand azeotropic mixture concept? Azeotropic mixture. Right. So now these azeotropic mixtures, again two types are there. One is called minimum boiling azeotropic and the second is called maximum boiling azeotropic. Minimum boiling and maximum boiling azeotrope. Till here understood or not? Concentrate here once again, 1 minute I will explain you. So, here we are discussing about the solutions, ideal and non-ideal, which follow Raoult's law, ideal which do not follow, they are called non-ideal solutions. Again, non-ideal solutions classified into two types. Okay. And then here before that we are going to the azeotropic mixture. So, azeotropic mixture means what? There is a mixture of two solutions with same boiling point, and where we cannot separate them by using the fractional distillation, right? Such type of azeotropic mixture, and these are two types are there, minimum boiling azeotropes and maximum boiling azeotropes. Two types are there. Okay, now let us see now. So, just now we discussed student this one, which obeying the Raoult's law, okay, ideal solutions, and this is non-ideal solutions, right? So, yes, here non-ideal solutions with positive deviation, and here two types of deviations are there. I will explain. Positive deviation is what? Negative deviations are there. Okay. So, ideal solutions, non-ideal solutions, we are discussing about the azeotropic. Now, in the two types of solutions are there. So, in that, so here non-ideal solutions are two types which shows positive deviation and negative deviation. Positive and negative. Positive and negative. Positive means what? Above, and negative means what? Below. Alright. So, students, now see here. Solutions that show the positive deviation. Solutions that shows positive deviation. So, the meaning just now we discussed. I am taking two solutions like A and B. Okay. So, students, here this I am taking pure A I am taking in one, and here I am taking pure B. This I am taking, this both I am mixing together. So, this is what? A plus B. Clear? Okay. Here the interaction between A and A. Here this is the interaction between B and B. Here I am checking this interaction between A and B. Right? A and B. Okay. In this, one is a solute, one is a solvent. Now see here. If a solution A and B are mixed, the interaction between A and B molecules is weaker than the interaction between A and B molecules. Means what? Here the force of attraction, force of attraction between A and A molecules, B and B molecules is greater than the force of attraction between A and B. Force of attraction between A and B. So, yes, here the interaction between A and A molecules, AB molecules is weaker than A and B and B. So, here I am taking the two solutions, I am mixing. If I am taking this A solution, many A molecules are there. So, the force of attraction between A and A is greater, and the force of attraction between B and B, this solution B and B, so this is also greater. But if I both mix, the force of attraction between A and B is weaker, means less stronger than these both the solutions. Are you following or not? Very simple. Okay. Now, the resultant mixture volume is greater than the sum of the volumes. Just now we discussed the ideal solution means what? In the ideal solution, delta V is equal to 0, means volume will not change. If I am taking 100 ml, we are taking 100 ml. If I am mixing both, I will get 200 ml. But in these cases, what happens? The volume may not be same, I told. Okay. So, in this positive deviation, what happens? The resultant mixture volume is greater than the sum of the volumes. Greater than the sum of the volumes. Okay. So, that is it. And the total vapor pressure of resultant mixture is greater than the sum of the vapor pressures of A and B. So, the meaning is what, students? Here, okay, listen carefully, If the meaning is that, okay, here what is given? The vapor pressure of the mixture is greater than the vapor pressure of N. If I take the A solution, A solvent, A liquid, and if I check the vapor pressure of this one, and what is the vapor pressure I explained you, okay, on boiling, the water, this liquid will be converted to vapor, that vapor exerts the pressure. So, the vapor pressure of A and vapor pressure of B, individually if you check, these both are greater, more than the vapor pressure of this solution, okay. Means, now what happens now? So, vapor pressure becomes more means what? Okay. So, more than actual, how much vapor pressure should be there? More than that vapor pressure. So, that's what it is called as a positive. What is called? A positive, right? For example, you see here, this graph we see, students, here, we are taking the two liquids, right? A and B. So now mole fractions of A is denoted by XA, mole fraction is B is denoted by XB. Now here we are taking on the x-axis mole fraction and on the y-axis we are taking the vapor pressure, right? For ideal solutions, how it will be vapor pressure? See now, okay? See this dotted lines, can you see? It is a straight, this is a straight one it's going, right? So, green color. So here you see the green color. So this is the for ideal solution. This is the ideal solutions, okay? So ideal solutions graph will be like this, okay? Like this. But here it is what? A positive deviation. Positive deviation means what? Little extra, yes or no? So here what happens, the graph will not be, okay, like on this one, but see here, you see, here it is going above like this, okay, like this. Here also see here it is going not like this, just above. Here also see, it's not like this, it's going like this. So this is called positive deviation. Clear to you? So positive deviation, right? Now negative deviation is exactly opposite, students. You can understand here. What you can write the negative deviations here. If the solution of A and B mixed, the interaction between A, B molecules is now here weaker, is there. So what you write now? Stronger. Stronger than the interaction between A and A, B and B are called as a negative deviation. Exactly opposite you need to write. And here also see the resultant mixture of volume is greater here there. But what you write there? Lower. Okay. So less than the volume of this one. The vapor pressure of the resultant mixture is greater, is there. So what do you write? Less than the, okay. And the graph, what it will come? Here graph will come like this, okay. I am drawing with the black pen. So here what happens here like this. Now down, negative, no. So it will come down like this, okay. Here also it will come down like this. Here also it will come down like this, okay. So that is about the vapor pressure. So here you see shallow, this one you see. So A and B solution mixed interaction, and here you see stronger. In the previous slide, what you have seen here? Weaker. But here you can see stronger. Now next term, here you can see what the here greater. And here you can see here less than. Okay, exactly opposite, students here. Vapor pressure is greater again. And here you can see here less than. Right? Now here what happens here? See, it's going red color line, going above the green color lines, above the green color lines. Right? Here what's happening? Here it's coming, okay, down here. Did you understand? So that is about the, okay, this one. And these are the some examples. See, this is water, ethyl alcohol. Okay. So like this, these are the some examples of minimum boiling. And this is the total overall, okay, overall concept what we discussed here in this one is here, ideal solution, non-ideal solution. Ideal solutions is what? Which obey the Raoult's law at any range of concentration, and non-ideal solution which you do not obey, do not obey. Clear? Now next, here delta H is equal to 0, I said, okay, but here the delta H is not equal to 0. Not equal to 0 means what? It may be greater or it may be less. So for positive deviation, say positive deviation, it is greater than 0, and for negative deviation, it is less than 0, right? Similarly, here vapor pressure also see here, the vapor pressure is equal here, but the pressure is greater here, the pressure is less. And you see the force of attraction AA, AB, BB all are same, so same. But here you see AB attraction force is weaker here and AB force of attraction is greater here. That's all, students. So that is the difference between, okay, this one. Clear to you? Yes? Chalo. Now in fast we can complete the exercise also. So open your exercise fast. Here just here examples only, students are there, nothing is there. Just once go through the examples, you can read this okay, synopsis, and we can give the answers. So now you see, open the page number 48. Which of the following liquid pairs show the positive deviation from the Raoult's law? Okay, in the examples, just you can see benzene and methanol is an example. So option is 2. Which of the following is non-ideal solution? Benzene, toluene, heptane, heptane, ethyl bromide, this all written. This one. Okay, carbon tetrachloride and chloroform. This is not written. I written this all the examination on the board. Okay, so answer is 4. Non-ideal solution was prepared by mixing 30 ml of chloroform, 50 ml of benzene. It will be, so here greater than 80, that's less than 80. Because it's non-ideal, so that may be greater or less than. So, or you can write the second is the option. Azeotropic mixture, constant boiling mixture. Boiling point will be same. Next, solution which is distilled without changing the composition of temperature is called azeotropic mixture. So, option is 2. The pair of solutions which shows a positive deviation in non-ideal solutions, that is not single carbon tetrachloride CCl3 positive deviation. So, C is the option, students. C is the right option. Next, a pair of solutions which shows a negative deviation in non-ideal solutions. Alcohol and stone, ether, stone and this one. Here all are the examples. So, you can 7th option is 4th option. Next, delta V is greater than 0. Then it is called what? Negative deviation. So, the answer is no deviation, positive deviation, 3. Negative deviation. A mixture of two liquids having the same boiling point. Just now we told azeotropic mixtures. So, option is 1. The liquid mixtures which display change in composition opposite to azeotropic, that is what? Geotropic mixture. Okay. So, these are the some questions. So, you can read this topic perfectly and then try to solve the remaining this one. Chapter is very simple, very easy. I hope you understood. Okay. So, students, with this we stop, and in the next class we go to the next synopsis. Until you take care of yourself and study well and follow the instructions given by your teachers and be obedient. Right?